Hello all, just making sure we're good. Yes, we are good. So here I am. I'm posting the second video, hopefully for week one. Just remember that these videos are a courtesy. They're not anything that's a requirement. I genuinely just want to give you all a better experience in this online class. So I hope you appreciate it. If you don't, let me know. If you don't need this, let me know, and I won't have to do it. But I think that you will enjoy having more practice problems. Who doesn't, right? All right, so we are going to integrate we're going to take a review of some integration rules. So Calculus 2 is all about integration. If Calculus 1 was all about differentiation, Calculus 2 teaches you how to integrate a lot. So we have to be very comfortable with integrating things that look difficult. Thankfully, though, we do have some strong techniques that can help us. One of those strong techniques, if we remember from Calculus 1, is u-substitution. U-substitution is very powerful. It helps us so much. So we're going to use it to help us here. So we want to integrate x divided by x squared plus 1 dx. And we're going to do this by u-substitution. So what I do whenever I see something like this is I think, okay, I can't manipulate that at all to anything nice to easily take the antiderivative. I have to use u-substitution. So remember what u-substitution says is you take a u, right? You take something in here and you set it equal to u. And then what you're going to do is you're going to take the derivative of that u. And I kind of separate it out from my integral. It's like a separate step, right? Now, remember with u-substitution, typically what you want to do is you want to make u the more complicated thing, or the thing that's in parentheses. So either the more complicated term or the term that's in parentheses is what is used in u-substitution. So what's more complicated here? X or x squared plus 1? I think we'd all agree it's x squared plus 1. So that's what I'm going to set equal to my u. So u is equal to x squared plus 1. Okay? In English, you find out who you are. In math, you find out what u is. It's a joke. All right, so we have that u is equal to x squared plus 1. So du is just the derivative of u. And that is just 2x. And we write it dx right here since we took the derivative with respect to x. Okay. So, what we do is we replace our terms. So, we replace u with the x squared plus 1. Okay? But we also want to replace this x. We want to replace all of our x's and replace them with only u's. But I have an x here and a 2x right here. So how do I do that? Well, what I have to do is I have to try and make this du equal to x somehow. Well, what I can do is I can divide both sides by 2. And when I divide both sides by 2, what I get is 1/2 du is equal to x dx. And so what happens is this x dx here can be replaced by the 1/2 du. So what happens is this is now equal to the integral of 1 over u du. So what happened? This x squared plus 1 became a u, and this x dx became a 1/2 du. My x dx became a 1/2 du because that's what it's equal to. So we have 1/2 times the integral of 1 over u du. Now we have to integrate 1 over u du. But what is the integral of 1 over u? Well, we have a rule here that we should remember from Calc 1. And it says the integral of 1 over x dx is equal to the natural log of the absolute value of x plus c. So this means that my integration here is 1/2 of the natural log of the absolute value of u plus c. And you need the plus c there because that's the arbitrary constant, right? Now, we have this in terms of u, but we want this in terms of x. So what is x? I'm sorry, but what is u? U is equal to x squared plus 1. So this is equal to 1/2 times the natural log of the absolute value of x squared plus 1 plus c. And that's our answer. All right, so I think that we can do another one. Pause to write it down. Okay. Okay, so the next integration that I want to do is I want us to integrate 1 over x times the natural log of x dx. All right, so how do we do this? Well, you probably guessed u-substitution. All right, so I want to do u-substitution. I'm going to check and see if I have time because these videos can only be 18 minutes long. So we always take our more complicated term and make it into the u. What's more complicated here, x or natural log of x? Natural log of x, I would say, most of us would agree, is more complicated. So our u is equal to the natural log of x. Now, what is my du? Well, what's the derivative of natural log of x? The natural log of x is 1 over x. And we write down the dx because we're taking the derivative with respect to x. Alrighty. So, with that said, now we do our replacement stuff again, right? So, what happens is my u replaces this natural log of x right here. And my du replaces the 1 over x dx. So all of this, okay, is replaced. Now, what does that look like whenever I do this? What this becomes is this becomes the integral of 1 over u du. There's nothing more complicated than that. Remember, what u-substitution does is it takes a complicated expression and it turns it into a more simple expression that we can integrate. Okay? That's all u-substitution is. And so we have our rule right here. So what this is equal to now, integrating it, is the natural log of the absolute value of u plus c. And what is u? U is the natural log of x. So I say that this is the natural log of the absolute value of the natural log of x plus c. And that's the answer. Pause to write it down. Okay. Hopefully we have time for 2 more. All right, the next one I want to share is a very quick one. It is the integral of x times e to the x squared dx. All right, so what's going to be my u? It's the most complicated thing in here, right? Well, we don't want to take e to the x squared. okay? Because we want our du to be something we can replace. So what I'm going to do is say, okay, I'm going to put parentheses around my x squared, and it's the x squared. My u is the x squared. So u is the x squared. So when it comes to e to the whatever problems you integrate, usually the u is whatever is the exponent of e. And so we have that du is equal to 2x dx. And we want to get that x by itself, so we divide by 2 on both sides, and what we get is 1/2 du is equal to x dx. Alrighty. So my u is the x squared, so that's taken. And my 1/2 du is equal to x dx, so all of this gets taken as well. And so what we have is this is equal to the integral of e to the u du. And it's 1/2 d to the u. Okay, because it's 1/2 du is equal to x dx. So I have to insert my 1/2 in there. All right, and so what's the integral of e to the u? Well, the derivative of e to the x is e to the x, so the integral of e to the x is e to the x, so the integral of e to the u is e to the u. So this is equal to 1/2 e to the u plus c. Now what is u? U is x squared, so this is 1/2 e to the x squared plus c. And that's the answer. So remember what we're doing is we're plugging that u right there. Pause to take a picture. All right. So one more. This one will be a little bit more complicated. Making sure I have time. I have 6 minutes for it. All right. So I want to integrate 1 over, well, this is going to be a definite integral. So from -1 to the square root of 3 of 1 over the square root of 1 minus x squared over 4. Let me move that 1 to right here, dx. So how do I do that? Well, one rule that you're going to learn in the inverse trig functions is that the integral of 1 over the square root of 1 minus x squared dx is equal to the inverse sine of x plus c. All right? So that's an important rule, and we're going to use this rule to solve this. All right? Let me get that one out of here. There you go. So, how am I going to do this? A combination of this rule and u-substitution. All right? So, that's what we're going to do. And some trig knowledge, because we need to remember our trig. So, what is this equal to? Well, I want to turn this into a form that I can use, okay? I want to get an x squared, a term squared. So I got x squared over 4, but I want to turn that x squared over 4 into something squared. So this becomes -1 to square root of 3 of 1 over the square root of 1 minus. And what this could be turned into is x divided by 2 squared dx. So this term and this term are the exact same thing, just changed up. They just look different. Now, from here, I have it in the form that I want to integrate, but I have to use u-substitution. I don't have just an x there, so because I don't have just an x, I have to use u-substitution. So my u in this case is the x over 2, and my du is the derivative of that, which is just 1/2 dx. All right, just 1/2 dx. And so now I substitute all my stuff. I substitute my u right there, and my du is 1/2 dx. So I don't have a 1/2 anywhere here, so what I can do is I can multiply both sides by 2. And so what I have is 2 du is equal to dx. I have a dx, so I can replace that. Okay? And in return, I give it a 2 du. So my dx turns into a 2 du. And so I take the integral of -1 square root of 3 of 1 over square root of 1 minus u squared. All right, there we go. Now it's in the right form, and so now I just integrate, and all of this integrates to the inverse sine. All right, I got 1 minute, so let's do this. So I have 2 times the inverse sine of u, and remember this is what you're learning on your chapter on inverse trig functions, and it is from square root of 3 to -1. All right, and so what this equals is 2 times, I'm just going to go ahead and write it out, 2 times the inverse sine of square, oh, and the u here is, let me just write that out, the u here is going to be x over 2. Okay, so that's what it is, x over 2. So this is going to be square root of 3 over 2, so that's what we're plugging in, minus the inverse sine of -1/2. And this is calculator work, honestly. So you just plug in your calculator or remember your unit circle. And what you have is you have 2 times pi over 3 minus -pi over 6, which equals 2 times pi over 2, which is equal to pi. And that's the answer. So a bit more of a complicated one for you, but I wanted to show you one that was more complicated. This is useful on your inverse trig rules that you're going to be learning about. All right, you all be good.